Hello everybody and welcome to Mr. Saucedo's YouTube videos. Today we're going to be going over our very first lesson in Unit 10, last unit. So we're going to be talking a little bit about climate and factors that affect it. First things first, what's the difference between weather and climate? You could think to yourself, but the real answer is that weather is something that changes very quickly. So it's the day-to-day conditions in the Earth's atmosphere, and as you are well aware, it changes every hour, every minute of every day, right? Go outside right now. It might be warm. An hour later, it could be, cloudy, right? So it's the very nature of the planet that we're on and the atmosphere itself really does kind of affect weather. Depending on what location you're in. Okay, what is climate? So they're not opposites, but climate is kind of what happens when you take average weather conditions and you measure them for a very long period of time, right? So here we've got the average temperature in Los Angeles from 1878 to 2008. So here we go. We've got in 1880-ish, it was around 62 degrees on average. And then by the time we get to 2008, it's, 66? No, well, somewhere around 67. But it is an average, right? So just like we were talking about isotopes a really long time ago in first semester, when we were looking at the average atomic mass, that doesn't mean that there aren't these dips. So you can see there are dips. It's just the dips are either, spread out irregularly, or, there are some years where it is significantly lower, and then it ends up coming back. Here's another picture, just to give you an idea of how that average bit is working. So this is the temperature of water off of the coast of Los Angeles, depending on the month, right? And so what do you notice? Well, obviously it's going to be the warmest in August, when we're measuring our beach water temperatures. And it's going to be coolest in the winter, January and February around here, right? So again, just patterns. That's all climate is. It's looking at patterns. So what are the factors that affect climate? There's a lot of them. Here's a picture to kind of give you the hint of the first one we're going to be talking about. Any idea what this diagram is kind of showing? It's showing the greenhouse effect. So the greenhouse effect is caused by greenhouse gases, and is kind of responsible for how life evolved on Earth and the fact that life evolved at all. So greenhouse gases are gases like CO2, water, yeah, that's right, like water vapor, like clouds, right? And CH4, which is methane, in the upper atmosphere. They trap heat from the sun. And so what are the main sources of greenhouse gases? Again, what do you notice? We've got electricity being the big one, transportation, industry, us, commercial and residential, agriculture, around 10%. So greenhouse gas emissions are caused by a variety of different parts of our economy. And the warming of the surface of the Earth by these gases is what we call the greenhouse effect. So without that greenhouse effect, literally, like I said, life either would have to evolved very differently, or it may not have happened at all. And just to give you a little brief glimpse at it, here's an animation for that.
The greenhouse effect was discovered in 1824, but what is it? Without the greenhouse effect, the Earth would be a frozen ball in space. While the majority of our atmosphere is oxygen and nitrogen, a small fraction consists of greenhouse gases, such as carbon dioxide, methane, and nitrous oxide, as well as other trace gases. Water is also a significant greenhouse gas. The greenhouse effect works like a blanket around the Earth by trapping heat radiated off the surface of the planet. It's the same as putting on extra blankets or clothing. By doing so, you trap more heat inside the layers.
Okay, so let's color code a diagram for the greenhouse effect. So in your notes, this kind of blob is representative of the Earth. So you can, either label that as, the surface of the Earth, which we are going to do anyway, or you can maybe draw a couple of continents and some ocean, water, and stuff like that. This is the atmosphere. So this kind of teal greenish stuff that I colored here, this is going to be our atmosphere, and then the greenhouse gases are in the atmosphere. This first arrow, this represents solar energy coming from the sun. It's going to hit the surface of the Earth, and it is going to be transmitted in the form of heat kind of back out. So you do want to show that the heat is originating here from the surface of the Earth. It's bouncing, and then it's coming back down. This is representative of the heat. So this is the greenhouse effect. The greenhouse gases are kind of preventing the heat from just escaping into space. Now, that does mean, though, that some of that heat is escaping into space. So that's what this arrow is representative of. So if you want to pause it, feel free to pause it, but take a look at our diagram here. Next up, latitude. So maybe you know what latitude is, but maybe you don't. Latitude is kind of where you are on the north-south kind of axis of the Earth, right? So it's kind of like, which ring are you at from North Pole to South Pole, midway point being the equator. And so latitude is very important for climate. More sunlight hits the equator than any other latitude on Earth, and that is because the Earth is tilted at a 23.5 degree angle. So we're tilted, you can see kind of right here. That's a 23.5 degree tilt. And that means that the surface of the Earth is being heated unevenly. Where have we seen that before? Well, when we were looking at plate tectonics, we also mentioned that, right? We said that the surface of the Earth cooled unevenly when it was cooling off and forming 4.5 billion years ago. Now, in addition to that, that uneven heating leads to very distinct climate differences. In other words, the North Pole, the South Pole are a lot cooler, the equator is a lot warmer, and then kind of depending where you are in relation to either the equator or the North Pole or the equator and the South Pole, you get all of these different climate biomes or distinctions. I guess I shouldn't say climate biomes. But you get these different climate distinctions which lead to different biomes. For example, tropical rainforests. Why do you find tropical rainforests primarily along the equator? Well, you get 12 hours of sunlight every day, and you also get 12 hours of nighttime, right? So that's very predictable and that's very regular. Whereas, where we are over here, depending on the time of year, we get significantly less sunlight in the wintertime than we do in the summertime. In addition to that, if you're in the North Pole, there's several, there's like a week or more throughout the year where the sun doesn't rise or where the sun doesn't set. So latitude plays a huge role in climate. The last one is heat transport. And so here's again, kind of showing a little bit of the heat transfer that we've already talked about with the greenhouse effect, but something that people often neglect when we're talking about climate here is that the Earth is rotating. And so because the Earth is rotating, that rotation is going to have an effect on how heat is transported from around the globe. And so that uneven heating of the Earth plus the rotation leads to distinct temperature differences. So we get this kind of rotational motion, which you can see here. We're not going to talk about the Coriolis effect or anything. You can take AP Environmental Science or Environmental Science if you want to learn more about that. But you get the idea, right? That we have these currents of warm air that originate at the equator, And as the Earth is spinning, that hot air is going to have to move. And so you get these little convection currents. And there's that word again, convection. So remember when we were talking about plate tectonics and continental drift, we talked about convection currents and about convection. That is also just as important when we're talking about climate. And in case you forgot, remember, convection is just the movement of a fluid. So in the case of plate tectonics, we were looking at fluids that were liquidy. Here, we're looking at fluids that are gas in the atmosphere or a liquid in the ocean. And so these temperature differences are what have created the wind and ocean currents that transport heat around the Earth that we are so well aware of, that we've known about for literally centuries, ever since we were ship-faring people. And that is dominated by the fact that the Earth is heated unevenly, it's warmer along the equator, it's cooler along where the North and South Pole are. And so because we are spinning around and spinning around and spinning around, it sort of bends the wind, and ocean currents are kind of dragged along by that motion. All right, that is it for lesson 1. If you have any questions, please let me know. Make sure you fill in your notes.